Well, so I throw another one in here. Maybe this would be one you might want to start with watching. I'm not going to go through all the rigmarole and all that, but we're just going to run through a couple simple ones. These are like the first few problems in your homework. I'm actually choosing to just do number 2 from your textbook and number 6 from your textbook. And get you started. I think some of these are just getting the basics down is pretty mellow with a lot of less words. So here it is. Here's number 2 from your textbook. Find two numbers whose difference is 100 and whose product is a minimum. All right, none of the whole word problem bullshit. I mean, I know there's words, but if you're struggling with this, you need to practice your frickin' algebra a little bit more. So what we got here is we got two numbers whose different. So two numbers. Let's say one of the numbers is x and one of the numbers is y, and their difference is 100. So we handled, boom, that part of it. Whose difference is 100. And whose product is a minimum. And what does product mean? Multiplication. So I don't know how you want to write this thing down. Maybe you're going to write it down, the product is equal to x times y. Maybe that's what you're going to do. Call it P. Call it smiley face. Call it something else. Doesn't really make much of a difference. Just call it something. Because all you're going to do is you're going to take that derivative, you're going to set that thing equal to 0, and you're going to ignore what P prime is called. But the game is, we don't want to go through this and take a derivative. Because there's a freaking product. Let's get this thing into terms of one variable. 1. So let's solve for y in terms of x. So let's take our x from over here. Let's move it over. We got our negative y is equal to 100 minus x. Let's multiply everything by negative 1. And we find out that y is just equal to x minus 100. You just turn around that subtraction right there when you change the sign. Now that we have it, we can just take it and pop that sucker on in. So we're like, all right, so the product is equal to x times, and instead of writing in, we're going to put in x minus 100. Dope. So the product is equal to, what, x squared minus 100x? And it's a parabola. And if we're trying to find the minimum, I think we're trying to find the vertex of that sucker. Well, let's go. Let's take a derivative, set that bad boy equal to 0, and let's finish this dang problem up. So let's say P prime. Let's call it that. Because what the hell else you want to call it? dP dx? Sure. Then we get 2x minus 100. Now remember, when we take a derivative, we want to set it equal to 0 and solve. That's how we find maxes and minimums. That's how we find peaks and valleys. Right? Take a derivative, set it equal to 0, solve, find out where. So once we set it equal to 0, we go 2 times our x minus 100 is equal to 0. Bring it over to x, and x is equal to 50. Duh. X is equal to 50. Well, then what the heck is y equal to? What's y equal to? Well, let's plug it back in. Let's go find out. So we just go to our constraint. Whatever we plugged in, we're like, well, let's put it right there. Like, well, I guess the y must equal x minus 100, but x is equal to 50. So I guess the y is equal to negative 50. And there we have it. So there we got it. Two numbers whose difference is 100 and whose product is a minimum. Let's go. Or if you kept going in the negative direction, you get the positive products, and that's why that doesn't work. So let's go to 4.7, number 6. What is the minimum vertical distance between the parabolas y equals x squared plus 1 and y equals x minus x squared? Really, all you got going on here is you got a parabola facing up and the y equals x squared plus 1. And then you got parabolas facing down with the one part. It kind of looks like this on the XY graph. Something like that. It's not perfect, but just getting the basic idea. Oh, look how I'm making that worse. So we want to find the minimum vertical distance between those two parabolas. So when we're talking vertical, I hope you're not thinking x. I hope you're thinking y. But what's weird about this is we're going to use all x's for this. So if we want to find the minimum difference, oh, oh, minimum vertical distance. Wouldn't that just be a difference? Wouldn't that be the one on top minus the one on the bottom? Let's look at that little I wrote in here. The distance between it, you know, from here to here, you know, the minimum distance we could possibly find. So those are the y values. We want to find the minimum difference of those y values. So why don't we take the one that's on top, our y, and let's subtract out our y that was in purple. Oh, shit. Oh, I mean, x squared plus 1 minus our y, which is x minus rx squared. And I think that would be a pretty good formula right there for saying some sort of distance between. So let's clean it up, and we're like, well, I think that negative goes through this one of these. What do we get? 2x squared minus x plus 1. I think that's what we got. Once we got that thing all rolling in, we're just going to take a derivative. We're going to set it equal to 0, and we're going to solve. All right, these aren't so bad, huh? Let's take a derivative. This time I'm going to call it d prime, because who cares? And we get 4x minus 1. We set it equal to 0, and we solve. Oh, shit, there it is. X equals 1/4. We found it. So we found that it happens that x is equal to 1/4. But that's not the answer. We just found where. We found where it occurred. All right, so when x equals 1/4, that's not what the question is asking us. It's asking us what's the minimum vertical distance. So what we need to do is take our 1/4 and plug it into both of them and find out what that distance actually is. We need to take it, that formula that we found right here. That's that distance. We just need to plug 1/4 on into there, okay? So we say the distance is equal to 2 times something squared minus a something plus 1, and then we just take this 1/4 and we pop it in. No big deal. So then we get 2 times 1/16 minus 1/4 plus 1. Little common denominators here and here. You got what? 1/8 minus 2/8 plus 8/8. It's called adding and subtracting fractions. So that's what? Almost this with -1. So what are we going to get? Is that going to be 7/8? I think it is. I think I've done something wrong. No, it's right. It's right. I don't know. I don't have any faith in myself today. You ever have those days you just think you're screwing everything up? So there it is. We got it. There's our minimum distance. Now there's no units to plug in because we're just talking like XY graph. So there are a couple problems. You have homework problems that are very similar to them. I would jump on and make sure that you get them done. Some real basics like this, because if you don't understand the basics, you're sure as hell not going to understand the more complex problems. So here's some basics. Get them done. Get them handled. So if you want to get some practice with that, I would do problem number 3 and problem number 5 that are very, very, very similar to what we just did here. See you soon.